Hi everyone. So in the last couple of videos, we've focused on evaluating functions. And by that, I mean we were plugging numbers into functions, right? Whether they were functions defined by tables or by formulas or piecewise functions, we've basically just been plugging numbers into functions. And so this video is going to kind of take that idea and take it a step further. And instead of just plugging in numbers, we're going to actually be plugging in algebraic expressions into functions. And if you don't know what I mean by an algebraic expression, don't worry, I'll explain what that means a little bit later. So I want to start with an example of just plugging in numbers just to kind of get the ball rolling. And I think by thinking about how it works to plug in a number, that will really help you see how it works to plug in an algebraic expression. So let's just start with a simple function. F of x is equal to x squared plus 4. So this would be a good place to pause the video and try to evaluate these two numbers. So I want you to find f of -3 and then also f of square root of 2. See what you get for those. Okay, so how does this work? Well, basically everywhere that you see an x on the right-hand side, whatever appears inside the parentheses here, you're going to replace x with that number, right? And so instead of saying x squared plus 4, we just say -3 squared plus 4. And one thing that is important, and this is why I chose a negative number, because I wanted to kind of point this fact out, is that when you're plugging in a negative number for x, it's important that you put parentheses around that number. And the reason for that is that you want to make sure that you're taking that entire number and squaring it. So I'll show you what would kind of go wrong if you wrote it a different way in a second. But let's figure out what this actually gives us. So if we take -3 and square it, well, a negative times a negative is a positive, right? So we get positive 9 plus 4. So we get 13. So what would be an incorrect way of doing this? So if you had instead written -3 squared without the parentheses plus 4, that would actually not be correct. And so why is that not correct? Well, if you have a negative sign that is not within the parentheses when you're squaring, that means that it gets applied after squaring. So if you had -3 squared, that would actually be equal to -9, because you would take the 3 and square it and then apply the negative sign afterwards. And then you would add 4 and you would get -5, which is just, that's not correct. So make sure, again, that if your intention is to take a negative number and square it, there should be parentheses around that negative number. Okay, so here we're going to do the same thing, except for instead of replacing x with -3, we're replacing x with square root of 2. So we're going to take the square root of 2 and square it, because that's what the function tells us to do, and then we're going to add 4. So for this one, if you have a square root of a number and you take that and you square it, it essentially cancels itself out. So the square root of 2 squared is just equal to 2. So we'd get 2 plus 4, which is 6. Okay, so just to kind of summarize what we did here so that it will be clear how to proceed when we get to the expressions, really what we did is, in order to evaluate f of, whatever that input is, all we did was replace every occurrence. Is that how you spell? I don't think that's how you spell occurrence. I think I put an extra R in there. Extra occurrence of, replace every occurrence of x with the input. So as I just mentioned, this also works, or I'll say it this way, this is also true for algebraic expression. So basically, what is an algebraic expression? So an algebraic expression is basically just a kind of a series of variables and numbers possibly connected by different operations. So things like x plus 2, or 3x minus 1, or 10x squared plus 5. Those are all examples of expressions. So an algebraic expression, I'll just write that as kind of a side note. An algebraic expression is basically just a sequence of variables and or numbers and or operations. So when I say operations, I mean things like addition, subtraction, multiplication, division. So yeah, so basically what's the difference between what we just did earlier and what we're about to do? It's that we're not just going to be plugging in a number, we're going to be plugging in either a new variable or some kind of a combination of variables and numbers. So I want to go back to our, I'm going to rewrite down our original function here. So our function was f of x is equal to x squared plus 4. I just want to have it written closer to what we're doing. Okay, so for example, let's say that we wanted to evaluate f of w. So what does that really mean? I mean, it actually doesn't mean that much, right? W just is another variable. It's not an actual specific number, but we can still apply the same kind of process that we did on the earlier ones, right? So what's the idea of evaluating a function? Well, you just take whatever is inside those parentheses, you take x and you replace it with that. So in this case, we would just say, okay, it's w squared plus 4, and that's it. So your answers on these are generally not going to be numbers, they're going to be algebraic expressions, because you're not just plugging in a number, you're plugging in something that involves a variable, so your answer will also involve a variable. So let's try another one. Let's try f of x plus 1. Okay, so what are we doing? Again, go back to the general idea with functions, which is that whatever is inside the parentheses, you're going to take that whole thing and replace x with whatever that is. Whatever's inside the parentheses, that's what x is getting replaced by. And so what that means is that instead of taking x and squaring it, we're going to take x plus 1 and square it. And then we're still going to add 4. Right? So we're just doing kind of following the same format as above. We're just taking where it says x, we're instead changing that to be x squared plus 1. So now let's actually expand this. Let's simplify this and write it a little bit nicer. So one thing I want to point out, because this is a very, very common misconception. So x plus 1 squared is not equal to x squared plus 1. So maybe let me say this kind of more generally. So I'll put my little warning sign up here. So generally, if you have anything, any two numbers or two variables being added together and you're squaring it, that's not going to be the same thing as just distribute. You basically can't distribute in the square. You can't just say, oh, it's just this thing squared plus the other one squared. So why not? Why doesn't it work that way? Well, because think about what it means to square something. So to square something means that you're multiplying it with itself, right? So if we have x plus 1 squared, that means that we should be taking x plus 1 and multiplying it with itself. So, in the same way that 5 squared is 5 times 5, x plus 1 squared should be x plus 1 times x plus 1. And then we still have this plus 4. And so now how do we multiply these two things together? Well, we have to use what you might call FOIL. So the general idea is that when you're multiplying, two things like this together, you want to make sure that every term gets multiplied with every term. So usually you might do something like this, like x times x, and that's x squared, and then x times 1, and that's x, and then you do 1 times x, and that's another x, and then 1 times 1 is 1. And then we also have plus 4 at the end. And so altogether, this gives us x squared plus 2x plus 5 would be our final answer. All right, let's do another one. And I encourage you to try this one yourself. So let's do f of 3x. Okay, so again, what we're doing is we're just going to take where we saw x in our original function, We're just going to replace that now with 3x. So this is another case where it's really important that you remember parentheses. So whatever is being plugged in as your input, that whole thing has to be squared. So that means we need to put the 3x inside parentheses. And then we still have the plus 4. And so what does it mean to take 3x and square it? Well, that means that you're multiplying 3x times 3x, right? And so what do you get when you multiply 3x times 3x? You get 9x squared. So it would not be correct to write this as, if you had instead forgotten the parentheses, if you had written instead just 3x squared plus 4, that's totally different than 9x squared plus 4, right? So that's why the parentheses are important. You want to make sure that whatever your function does, it needs to be doing that process to everything that's inside your parentheses here. So in this case, that means we're squaring that whole thing. All right, let's do one more with this function, and then we'll see something a little different, and then we'll move on to another function. Okay, so let's say now that we're doing f of negative x. So again, we're just going to take our x and replace it with negative x. So we have negative x squared plus 4. So this one can be simplified in kind of a nice way. So remember that when you have a negative number and you square it, it becomes positive, right? And so what that means is that negative any number squared is the same as positive of that number squared. So we can rewrite this as just x squared plus 4. So I'll make kind of a note of that. That's kind of a special piece of information. So for any number x, negative x squared is the same thing as positive x squared. It's not the same, by the way, just to kind of bring up something we mentioned, that's not the same thing as having the negative sign on the outside. If you have the negative sign on the outside, that means that you're squaring the number and then applying the negative sign. So that's different. But as long as the negative sign is inside the parentheses, it's going to give you the same result as if the negative sign was not there. I'll put my little warning sign there again. Okay, so I want to bring up one other thing that's a little bit different, still with this same function actually. So let's say that you're going back actually, let me scroll back up to it. So I think the second example we did, sorry, my mouse is stuck. There we go. So the second example we did was f of x plus 1. So I want to do a slightly different example now, which is I want to do f of x plus 1. So I first want to think about, how is that different from f of quantity x plus 1? Well, f of x plus 1, so this one, that is asking you to plug in x plus 1 for x, right? It's asking you to replace x with x plus 1. That's not what this one is asking you to do. This one is saying, what is getting plugged into the function? Well, just x actually. So that's just the original function. This is just your plain old regular original function f of x. And then we are adding 1, but we're actually adding 1 afterwards, right? We're not plugging 1 in anywhere. We're just kind of tacking it onto the end. And so to evaluate this one, we would just take our original function, which was x squared plus 4. So we're not replacing x with anything. We're just leaving it as x. And then we would add on plus 1 at the end. And so we would get all in all x squared plus 5. So I just wanted to point out that distinction that, you can basically add a number, to the function, and that can be different from plugging the number into the function. So just pay attention to, basically just comes down to what is actually inside those parentheses for the function. Okay, I want to try another one that is going to be a little bit trickier just because it's a slightly more complicated function. So I would encourage you though to try these examples yourself, these next couple of examples. So we're going to use the function g of, let's mix our colors up, I'll use blue. G of x is equal to 5x squared minus 2x plus 3. And so what I want you to evaluate is I want to do g of x minus 2. And then I also want to do g of x minus 2. So I'd encourage you to pause the video and try this yourself and then come back and check whether you got the same answer. And if you didn't, then you can watch through the process. Okay, so how do we do this? Well, it's basically the same thing that we did on the previous example, right? So we're going to take our function, and every time we see x in our original function, we're going to replace that x with x minus 2. And so we're going to get 5 times x minus 2 squared minus 2 times x minus 2 plus 3. So everywhere that we saw an x in the original function up here, I'm just replacing that x with an x minus 2. Okay, so how do we go from here? Well, we want to be able to kind of simplify this and combine like terms and all that. So I'm actually going to, just because I think I'm going to run out of space, I'm going to erase this g of x minus 2. I'll just do that below once we're done with this one. Okay, so what is x minus 2 squared? Well, x minus 2 squared is x minus 2 times x minus 2. So we can rewrite this as 5 times x minus 2 times x minus 2. And then here we can distribute this 2 in, right? So we can distribute negative 2 into the x and into the negative 2. So that's going to give us minus 2x. And then we have negative 2 times negative 2, and that's plus 4. And then we have a plus 3. Okay, so now we can multiply together this part, right? We want to multiply these two things together the same way we did on the previous example. So we want to multiply together x times x times negative 2. So that's going to give us 5. So the 5 still stays on the outside, and we're kind of just working on multiplying those two together. So we get x squared minus 2x. We get another minus 2x. And then we get a plus 4. And then we still have this minus 2x, and then we can combine here. We have plus 4 plus 3, so let's make that plus 7. And so this all together, we can, let's actually simplify the inside of the parentheses first, and then we'll distribute that 5. So this is x squared minus 4x plus 4 minus 2x plus 7. Okay, so now we can distribute this 5, and so we get 5x squared minus 20x plus 20 minus 2x plus 7. And now all that's left to do is to combine our like terms. So we have 5x squared minus 22x plus 27. And that is our final answer. So just to point out, the kind of important things here, again, we started by just replacing every occurrence of x with x minus 2. And then the important thing is to make sure that you're actually multiplying out the x minus 2 times x minus 2. So remember that it would not be correct to say that x minus 2 squared, that's not the same as x squared minus 4, right? You can't just distribute in that square. And then the other thing that I think could be easy to make a mistake with is that this 5 is on the outside, right? So you want to make sure you keep that 5 on the outside and distribute it in once you've already multiplied together the x minus 2 times the x minus 2. The 5 isn't getting squared, right? If the 5 was supposed to get squared, then there would be parentheses like this, but there aren't. And so whenever there are no parentheses and you have kind of a number attached to x squared, that means that number gets multiplied in afterward. Okay, so other part that I asked you to do is going to be way quicker. So the other thing I asked you to do was to find g of x minus 2. So what is g of x minus 2? Well, that just means that we're going to take our original function g of x, so 5x squared minus 2x plus 3, so that's the g of x part, and then we're just supposed to subtract 2 from that. after the fact. And so this would give us 5x squared minus 2x plus 1. Okay, so there's one more thing I want to talk about in this video. It's basically just kind of an application of the ideas that we've been working with so far. So by the way, everything that we've covered so far in these videos, we're basically just building up the skills that we're going to need to tackle the kind of more complicated concepts later on. So, like I said, a lot of this is review, and a lot of this is really just kind of getting comfortable. And especially this video, I think, is just getting comfortable with your algebra, refreshing your algebra skills, because things like this will come up later, not only in this class, but in later on classes. And so specifically, if you take Calculus 1, you'll see a specific type of expression that is called a difference quotient. So a difference quotient is an expression of the form f of a plus h. Sorry, I was just debating whether I wanted to use colors. I'll use some colors here. Let's say f of a plus h minus f of a all divided by h. So we're not going to be talking in this class about, what is like the meaning or the purpose of the difference quotient. We're just going to be practicing doing the algebra of kind of creating it. So I'll just briefly tell you, what it's used for. So in Calculus 1, so the difference quotient is used in Calculus 1 to calculate the slope of a line called a secant line. So I'm not going to get into this. If you're really curious, if you look at my Calc 1 videos on YouTube, I think probably my very first video in for 151 is about this topic, first or second video, if you're really curious, or you can just wait till you get to calculus to see it. But yeah, like I said, we're not going to be worrying too much about this whole slope idea. We're just going to be kind of calculating it. So let's say that we have a function f of x is equal to, we're going to keep it simple for the first one. Let's just do x squared plus 4. So same one from earlier. And actually for both the examples we'll keep this simple, because we'll see that this expression actually gets pretty complicated pretty quickly. So we'll be doing it for fairly simple functions for now. Okay, so let's find the difference quotient. So the difference quotient, again, just to remind us, that looks like f of a plus h minus f of a all divided by h. So what I would recommend in order to put this together, there's kind of a lot going on, right, in this little expression. And so I would kind of take it piece by piece. So I want to focus first on figuring out what f of a plus h is. So that's what we'll do first. And then we'll figure out what f of a is, and then we'll put those back together and put the h in the denominator. Okay, so how do we find f of a plus h? Well, we just do the same thing that we've been doing so far in this video, right? We're just going to take our original input of x and replace it with a plus h. And then we have plus 4. So, this might look like maybe you're not used to doing algebra with a and h as your variables, but it's just the same as, everything else we've been doing here. So what does it mean to do a plus h squared? That means we're going to do a plus h times a plus h. And then how do we multiply together a plus h times a plus h? Well, the same way that we multiplied things together earlier. So we do a times a, and that's a squared. We do a times h, and that's a h. We do h times a, and that's ha, which is the same thing as AH. It's just the opposite order. And then we do H times H, and that's H squared. And then we have plus 4. So we can simplify this. As I just mentioned, we just said that AH is the same as HA, right? It's just written in the opposite order. So we can rewrite this as 2 times A times H plus H squared plus 4. So that's what we're going to put in as our f of A plus H part. And then the only other piece we need here is we need to know what f of A is. So f of A is just taking our original function and replacing x with A. So we have A squared plus 4. And so let me just color code this a little bit. That is our f of A. So now that we have both f of A plus H and f of A, now we can put them together into this expression. So I'm going to write that down here below. So we're supposed to put f of A plus H first. So that's A squared plus 2AH plus H squared plus 4. And then from that, we're supposed to subtract f of A. And f of A came out to be A squared plus 4. And so it's really important that you put parentheses around the A squared plus 4 because we're supposed to subtract that whole thing, right? Like the original problem tells us to subtract f of A. And so if f of A ends up having more than one piece to it, you need to put parentheses to make sure that that whole thing is getting subtracted and not just part of it. And then we're supposed to take this whole thing and divide it by H. Okay, so let's see what this simplifies to. So we have A squared plus 2AH plus H squared plus 4. And then we have minus A squared minus 4, and that's all divided by H. Okay, so now we can look for some stuff that could cancel out. So we have an A squared and a negative A squared. So those are going to cancel out. And then we have a positive 4 and a negative 4, so those are going to cancel out. And so we're left with 2AH plus H squared, all divided by H. And so now, because we noticed that the stuff that canceled out in the numerator was all the stuff that did not have an H in it, right? Once we canceled out the A squareds and the 4s, now everything in the numerator has an H in it. And so that's going to enable us to actually simplify this expression further. So what we can do is we can factor out an H from the numerator, and we'll be left with 2A plus H. And so why do we want to factor that out? Because once we factor it out, we can see that the numerator and the denominator have a common factor. And so when the numerator and the denominator have a common factor, that allows you to cancel it out. And so our final answer here is 2A plus H. So basically what did we do? We started with this kind of complicated looking expression. We figured out what f of A plus H is. We figured out what f of A is. Once we had those, we put them back into this expression, and then we just did a lot of simplification. Another kind of warning sign I just want to tell you, it would not have been correct to start canceling out the H while we still had terms in the numerator that did not have an H in them. So it's really important that in general, and I'll remind you of this throughout the quarter when it comes up, but when you have a fraction, you can only cancel something in the numerator and denominator if it's a common factor of the numerator and denominator. And so you basically should be able to factor that whatever that variable is out of everything in the numerator. And so that's why notice we were able to factor out this H. If this had been like, let's say 2AH plus H squared plus 1, we would not have been able to cancel that H out because we wouldn't have been able to factor an H out from the 1. And so it's really important that you recognize that when you're doing a cancellation like this, you must be able to factor whatever it is you're canceling. It has to be a factor of everything in the numerator. Okay, so let's do one more example of this difference quotient idea. And so now that we've done one, I would encourage you to try this next one yourself. So for this one, let's say that our function is g of x is equal to 2x plus 5. And so again, we're going to find the difference quotient. So we want to find g of a plus h minus g of a, all divided by h. Okay, so let's break this down again and kind of do it piece by piece. So let's start by figuring out what g of a plus h is. So g of a plus h, that means that we're going to be replacing everywhere we see x in our original function, we're going to replace it with a plus h. So we have 2 times a plus h plus 5. And so that simplifies to 2a plus 2h plus 5. So the algebra is definitely a little bit simpler on this one because our original function isn't getting squared. So that's our g of a plus h. And then what is g of a? Well, g of a just means that we're replacing x with a. So it's going to look just like our original function, but instead of having an x in it, it will have an a in it. So that's going to be 2 times a plus 5. So that is our g of a. And now we can put these together. So we're going to end up with first this 2a plus 2h plus 5 minus, and then remember again, parentheses, 2a plus 5. And then that whole thing is going to get divided by h. Okay, so we can distribute in that negative sign. So we get minus 2a minus 5 divided by h. And now we can look for stuff to cancel out here. So we can see that we have a positive 2a and a negative 2a. So those cancel each other out. And then we have a positive 5 and a negative 5, so those cancel each other out. And generally speaking, with these difference quotients, if you're doing it correctly, that kind of thing is going to happen. You'll see some cancellation happen, and it's going to be cancellation that will then enable you to have a common factor in the numerator and denominator. So in this case, we have 2h over h, and so we can get rid of that common factor of h, and we're left with just 2 as our answer. All right, so that is it for this video. So as usual, I really recommend that you check out the worksheet for today so you can get more practice. I think out of everything we're doing, I think this is probably the thing that you really have to kind of get your hands dirty and do it yourself to really get that practice with the algebra. That is going to be really important when we move into more conceptual stuff later in the quarter. All right, I will see you all in the next video.